Okay, we're at the point to where we'll introduce the actual antiderivative rules. And these should look very similar to the derivative rules. We're just reversing the process. So the constant rule. If we want to integrate a constant, it's kind of like, for example, the integration of like 3. Where would 3 come from in taking a derivative? It would have came from 3x. So don't forget that plus c we talked about, but if you had a number, you want to take the antiderivative of it, it would pick up an x or whatever the variable was that dx was representing. Okay, so just think about how you would reverse the derivative process. How would you have gotten there? Okay, the next one, reverse power rule. If you started with x raised to a power, x to the n, we're going to go backwards. So what we're going to do is the opposite of what we do when we took the derivative. When we took the derivative, we multiplied by the power and then decreased the power. Well, in this case, we're going to increase the power and then divide by it. So a little quick scenario there would be x squared. If we wanted to integrate that, take the antiderivative, it would go up to x cubed, and we would divide by the 3. Don't forget the plus c. Okay. The sum difference rule, basically if you wanted to take the antiderivative of two functions added together, you could do that separately. So I don't think I really need to write anything down here. This is basically the idea that if we had polynomials or something, we could kind of work them together. Okay, we'll see some examples before and later. And the constant multiplier rule here, if you had a number times a function, okay, you want to integrate it, the number just sits there. Remember, coefficients just hang out. Okay, and then you could integrate the function. So more or less going back to something earlier, if we had 3, well, let's change that. If we had 5x squared and we wanted to take the antiderivative of that, we would say that would be 5 and then x cubed as it gets increased, and we'll divide by the 3. So the 5 just sits there. You can make it a multiplier. You can incorporate it into the fraction, but we're just reversing the process, and the 5 just hung out. The exponential rule for e, the antiderivative of e to the x is e to the x, of course, plus c. Remember that taking a derivative of e to the x was pretty boring at first. When we get around to trying to incorporate how we handle a chain rule, take that backwards, it'll be more interesting. But right now, if you see e to the x, the integration or the antiderivative is e to the x. And the natural log rule here, remember that in the very beginning, the basics was the derivative of natural log of x was 1 over x. So we'll reverse that. The antiderivative of 1 over x is the natural log of x. And every one of these, in the way they're written, gets that plus c. So that's just what we're going to have. Okay, let's do a couple of examples so you can get used to it. So we're going to take the antiderivative of 3x to the 4th plus 5 over x squared minus the square root of x. And this is in terms of dx. So just like when we took the derivatives, let's rewrite things that we see powers and powers in the top. So we'll just rewrite. 3x to the 4 is okay, but this 5 over x squared, let's bring that x squared up as x to the negative 2. And then minus the square root of x, let's write that as minus x to the 1/2. So just like you were going to take a derivative of this thing, rewrite it so that you see exponents. Okay? So then we can reverse our rules. It's 3 different things added or subtracted together, so we can do all 3 separately. The first part here, we're going to reverse that power rule. So x to the 4th goes up to x to the 5th. The 3 hangs out, and I'll divide by that 5th power, so it'll be 3/5 x to the 5th. The next part we're going to work with is 5x to the negative 2. So we'll increase that to negative 1. So that'll be 5 over negative 1. So I'll just write it as negative 5 over 1, which we could just write as negative 5 x to the negative 1. The last part here, minus x to the 1/2 power. So we'll make that 3/2 as we increase it. We'll keep the minus 1 out there. We're going to divide by 3/2, So that's the same thing as keep, change, flip. So that'd be multiplying by 2/3. And let's don't forget our plus c. So I'll clean this up a little bit. I don't think it needs much cleanup, but it will be 3/5 x to the 5th minus 5x to the -1 minus 2/3 x to the 3/2 plus c, if you want to clean it up. Okay. Just be careful with them. You're doing something new. It's easy to get confused and do a derivative rule since they seem similar. The next thing we're going to do is the example, the antiderivative of 7/x. I'm going to rewrite this as I go as I need to. So that'll be the antiderivative. I'll just pull the 7 out to the side as a coefficient, and it'll be times 1/x. And then plus 3x to the -4/3. So I don't think that needs to be rewritten. And then plus e to the x. That can't be rewritten. So it wasn't a whole lot of gain in rewriting it, but it may help you. So let's see here. This is 7 times 1/x. We know the 7 just hangs out. It's a coefficient. And then the 1/x backtracks to the natural log of x. Okay. And then we'll have the 3. And then we'll have x to the -4/3. So we'll add 1 to that. So it'll be to the -1/3. And then we could say we're going to divide the 3 by -1/3. We'll clean that up in a second. Hopefully we'll have enough room for it. And then we're going to say plus the antiderivative of e to the x is e to the x, and we won't forget the plus c. So let me see if I can rewrite this a little bit better. It'll be 7 natural log of x, and then 3 divided by -1/3 is minus 9 x to the -1/3 plus e to the x plus c. Once again, how much cleaning up you do and simplifying is really up to you. Doesn't bother me too much. Just do your best. The last one down here, just glancing at it, I don't think there's anything that needs to be rewritten, but it says the antiderivative of 6 minus x plus 1/5 x to the 3rd plus 4x to the -5. And we're going to handle this in terms of x. So let's see. 6 becomes 6x. Negative x becomes x squared, but we'll divide by that too, so it'll be -1/2 x squared. And then we're going to have plus, there's a 1/5 there, so the x to the 3rd goes to the 4th, and when we divide by that 4, we'll have 1/20. And then the x to the -5 goes to the -4. We'll divide by that, so 4 divided by -4 just gives me -1. So plus c. So just kind of watch that and make sure you're getting the right things. Plenty more examples will do, but hopefully this is helping you get the basics of just using the rules. Thank you.